Good day, everyone! For this day, we'll be discussing Chapter 4 or the Project Management. Managing large scale, complicated projects effectively is a difficult problem and the stakes are high. The first step in planning and scheduling a project is to develop the what we called work breakdown structure. So, time, cost, resource requirements, predecessor activities, and people required are being identified for each activity. A schedule for the project then can be developed. The program evaluation and review technique, or the PERT, and the critical path method, or the CPM, are two popular quantitative analysis techniques to help plan, schedule, monitor, and control projects. Originally, class, the approaches differed in how they estimated activities. PERT used three-time estimates to develop a probabilistic estimate of completion time, while CPM was a more deterministic technique. However, they have become so similar they are commonly considered as one technique now called the PRT slash CPM. We have here the General Foundry example of the PERT CPM. General Foundry Incorporated has long been trying to avoid the expense of installing air pollution control equipment. The local Environmental Protection Group has recently given the foundry 16 weeks to install a complex air filter system on its main smokestack. General Foundry was warned that it will be forced to close unless the device is installed in the allotted period. They want to make sure that installation of the filtering system progresses smoothly and on time. So these are the activities and immediate predecessors of the General Foundry Incorporated. We have here in the first column the activity, second the description, and the third the immediate predecessor. Activity A is build internal components. Activity B, modify roof and floor. If you observe, there are no immediate predecessors for activity A and B. Activity C, construct collection stock. We have here immediate predecessor activity A for activity B. C rather. This means, class, that you cannot construct collection stock unless you are done with its immediate predecessor, which is activity A, build internal components. So in other words, you need to finish first building internal components before you can proceed with constructing collection stock. The same with activity D, pour concrete and install frame. You need to finish first activity B, or the immediate predecessor, that is modifying roof and floor, before you can pour concrete and install frame. For activity E and F, they have the same immediate predecessor, which is C. So you cannot build high temperature burner and install control system unless you are done constructing the collection stock. And for G, install air pollution device, your immediate predecessor is 2, activity D and activity E, meaning you can proceed with installing air pollution device when you are done with pouring concrete and install frame and building high temperature burner. And for the last activity H, inspect and test, you must be done with F and G, your immediate predecessor, which is installing control system and install air pollution. In other words, class, immediate predecessors are the activities required so that you can move on with your next activity. So we need to draw the PERT or CPM network. So when you say drawing, we need to present a diagram. So there are two common techniques for drawing the PERT networks: the activity on node or the AON, where the nodes represent activity, and the activity on arc or the AOA, where the arcs are used to represent activities. The AON approach is easier and more commonly found in software packages. One node represents the start of the project, and the node for the end of a project, and the nodes for each of the activity. The arcs are used to show the predecessors of each activity. So let's take a look the network. So this is the network for the General Foundry. As you can see, we have here the start. Okay, then start, we can simultaneously, okay, when you say simultaneously, pwede na ito madungag trabaho ang activity A and activity B. We can altogether work activity A, build internal components, and we can also work, modify roof and floor. So, pwede siya dunganon activity A and activity B. Then, activity A, after activity A, you should construct collection stock. So, activity A is the predecessor for activity C, as we've discussed earlier. Meaning, class, you cannot proceed with activity A if you are not done yet with activity A. So, you cannot proceed with activity C, rather, if you are not done yet with activity A. The same with activity D, you cannot pour concrete and install frame if you are not done yet with modifying roof and floor, which is activity B, because activity B is the predecessor activity of activity D. Then after letter C, if you're done with C, you can simultaneously proceed with F and E. You can install control system and you can build a burner. Then after D, you can proceed with G, install pollution device. Okay. Then uh you need to finish E and D so that you can proceed with letter G, because E and D is the predecessor activity of letter G. For letter H, class, the predecessor activity is install control system and install pollution device. In other words, you cannot inspect and test if you haven't done yet activity F and activity G. So after activity H, that is the end of your activity, which should be finished before week 16, because the General Foundry Incorporated is only given 16 weeks. So it should be better if you can finish it before week 16 para dili sila matanggalan og permit and they can still operate. Okay? In some situations, activity times are known with certainty. When you say certainty, we are sure. However, there are times when activities are not sure. The CPM assigns just one time estimate to each activity, and this is used to find the critical path. In many projects, there is uncertainty about activity time. So when you say uncertainty, meaning you're not sure, PERT employs a probability distribution based on three time estimates for each activity, and a weighted average of this estimate is used for the time estimate, and this is used to determine the critical path. So, PERT often assumes time estimates follow a beta probability distribution. The time estimates in PERT are optimistic time and activity will take if everything goes as well as possible. Pessimistic time and activity would take assuming very unfavorable conditions. And most likely time, this is the most realistic time estimate to complete the activity. To find the expected activity time, or T, the beta distribution weights the estimates as follow. T is equal to A plus 4M plus B all over 6. And to compute the dispersion or variance of activity completion, we use the formula variance is equal to B minus E all over 6 raised to 2. So this is the time estimates for the General Foundry incorporated in weeks. So as you can see here, column number 1 or the first column, we have here activity A, B, C up to H. And second column is the optimistic time. Third column is the most probable time. The pessimistic column is the fourth column. And the next is the expected time. Expected time is what we have discussed earlier. T is equal to A plus 4M plus B all over 6. And the last column is the variance, or this is equal to B minus E all over 6 raised to 2. So the activity we have here the optimistic, most probable, and pessimistic time. Then we have here the expected time and the variance. So let us see how to calculate the expected time as well as the variance. Let us take for example activity A. So this is the example. Expected time for activity A, we have here expected time is equal to A plus 4M plus B all over 6. So let us take a look. Pila ang A, pila ang M, and pila ang B. For activity A class, A is 1, M is 2, and B is 3. So we have here, we will only substitute A is 1, M is 2, and B is 3. So this is 1 plus 4 multiplied by 2 plus 3 all over 6. So this is 1 plus 8 plus 3 all over 6. 1 plus 8 plus 3 is 12 all over 6. So 12 divided by 6, that is 2. So the expected time for activity A is 2. So this is expected time for activity A is 2. Now we will calculate the variance. Variance is equal to B minus E all over 6 raised to 2. So we know that A is 1, M is 2, and B is 3. So we have here B is 3 minus A is 1. So 3 minus 1, this is 2 all over 6. And then raised to 2. 2 times 2 is 4 and 6 times 6 is 36. So this is 4 over 36. So the variance here is 4 over 36. So we now get the expected time and the variance. So for the rest, activity B, C, D, E, F, G, and H, you will calculate this in your own, and this will be your learning task for this topic, project management. And then, how to find the critical path. We accept the expected completion time for each task as the actual time for now. The total of 25 weeks in Table 12.2 does not take into account the obvious fact that some of the tasks could be taking place at the same time. Okay, let's take a look back at Table 12.5. For expected time class is this column, second to the last column. We use the expected time. This is the time or how long each activity can take. Let's say, for example, activity A can take up to 2 weeks. Activity B can take up to 3 weeks. And if you will sum that all, that will be total to 25 weeks. But take note that we can do activities together. So when we will go back to our network, take note that we can simultaneously do some of the activities. We can do activity A and B together, and C and D together, and we can do activity F and G together. So you cannot, it is not necessary that you will finish A to proceed with B, because you can do A and B together. So this activity time that we are showing in table 12.2 is in consideration if we will do this activity one by one. But take note, we will not be doing this one by one because there are activities that can be done simultaneously. simultaneously. So the total 25 weeks in Table 12.2 does not take into account the obvious fact that some of the tasks could be taking place at the same time. To find out how long the project will take, we'll perform the what we call the critical path analysis for the network. The critical path class is the longest path through the network. Okay, we will find now how to find the critical path. So the general foundries network with expected activity time. So this 2, 2, 2, 4, 2, 3, 4, 5. These are the activity times class that we have calculated in our table 12.2. So kani siya, expected time or the activity time, we will put we'll put this in our network. So mo ni siya. Expected time for activity A is 2, activity B is 3, expected time for activity C is 2, D4, E4, F3, H2, and G5. So this is our first step. Then we have uh, next step. So this is now the next step. So how did we come up with this network? So we will backtrack a little bit. We have here, to find the critical path, we need to determine the following quantities for each activity in the network. We have what we called the ES, or the earliest time start. The earliest time start is the earliest time an activity can begin without violation of the immediate predecessor requirements. Meaning, mo ni pinakasayo nga posible nga magsugod ang atoang activity. Earliest finish time, the earliest finish at which an activity can end, and the latest time, start time, is the latest time an activity can begin without delaying the entire project, and the latest finish time is the latest time an activity can end without delaying an entire project. So, in the nodes, the activity and the early and late start and finish times are represented in the following manner. So, activity mo to activity A, ang T is the time or the number of weeks, example 2. ES is the earliest start. EF is the earliest finish na time. LS is the latest start, and LF is the latest finish. Earliest times class are computed as earliest finish time is equal to the earliest time and the expected activity time. So you will add earliest start plus time. So kani, when we will compute the EF, kani, we will add the earliest start plus time so that we can get the EF. Again, how to get the EF? This is given and this is given. Earliest time start plus time in every activity is equal to the EF. Okay. Then earliest start is the largest of the earliest finish times of the immediate predecessors. So largest EF of the immediate predecessors. Okay. So we have here at the start of the project, we set the time to 0, di ba? Earliest start 0. Kaya wala pa man ta. Pwede man ta ka-start at 0 kay start pa man siya. So since A and B, pwede na to siya madungan. Since activity A and B is pwede siya madungan, we can set is earliest start for A is equal to 0 and earliest start for B is also equal to 0. For A, if you will look at table 12.2, the time is 2 expected time, and for B, the time is 3. So how to calculate EF, earliest finish? Earliest finish is earliest start plus time, that is 2, and for letter B, earliest finish is earliest start, this 0 plus 3 activity na siya is equal to 3. So let us take a look at this activity, at this network. So we have here activity A and activity B. Activity A class, natay time nga 2. We said earlier that our earliest start is 0 for activity A kay wala man kay nag-una nga activity. So we can start at 0, earliest start ni siya nga time. Earliest start nga time na to is 0, and then plus time na to. How to get, this is the earliest time start, and this is the earliest finish. Earliest start, earliest finish. Unya, T. How to get the earliest finish? You will only add earliest start plus time. Makuha na to ang earliest finish. Same with activity B, our earliest start time is 0, and our time, katong gi-compute na to ganyan na T, expected time, nasa table, 3. So, to compute earliest finish, we will add earliest start 0 plus 3 is equal to 3. So, for activity C, time is 2. Na siya sa table. Earliest start na to is 2. Where did we get the earliest start? Here. Mo ni siya earliest start na to. Kay mo ni siya ang earliest finish. So, carry over 2. Earliest start, you will add with the time, mahimo siyang 4, that will be the earliest finish. So the same with here, letter D, the time is 4. We will have earliest start here is also the earliest finish. Carry over the earliest finish here will make the earliest start. Earliest start plus time is equal to 7. So N, it will continue. For F, the earliest start will be the earliest finish for the predecessor activity, which is C. So 4 plus 3 is 7. For E, the earliest start is the earliest finish of the predecessor activity, which is C. Still 4, carry over 4 plus 4 is 8. For G, ang earliest niya nga start is the earliest finish sa atuang predecessor activity. If you can earliest finish, as you can see, natay duha ka predecessor activity sa atong G. Activity E and activity D. So we cannot say nga atong earliest start kay 7 because it could be nga dugay mahuman atong A. At 8, di ba? Mas dugay mahuman ang A na to. 8 siya, 8 weeks. Samantalang ang atong D kay 7 weeks. And we say that the predecessor activity for E and D, for G should be E and D, meaning dapat mahuman atong E and D para makaproceed ta sa G. And the earliest finish na to dire kay 8. Diba? Kung 7, makuha na ta, matrasaw na ta sa oras, so diri na to i-base earliest finish na to sa E. So, earliest finish diri, ang pinakadako nga earliest finish atong i-carry over sa next. So, same po diri, ang H, a predecessor activity is F and G. Ang pinakadako na to nga earliest finish, we have two earliest finish for F and G, 7 and 13. Ang pinakadako nga earliest finish na to class kay 13. So we carry over the earliest finish here diri sa H. So we will add 13 plus 2. This is earliest finish na to is 15. Earliest start, earliest finish, mahimo siyang 15. So in other words, if we will follow this critical path, we have a network, mahuman na to ang ato ang activity in just 15 weeks. Given nga natin mga activity nga dungan-dungan na to simultaneous. So, di tayo magpaabot og 25 weeks, but rather we can finish it in 15 weeks. We are now done with the earliest start and the earliest finish, and we will move on with the latest start time and the latest finish time. When you say latest start time, this is the latest finish time minus expected activity time. And the latest finish time is the smallest of the latest start times for following activities. So we will take a look at the network so that we will understand more what we are saying right now. So this is activity A. Expected time is 2, earliest start, and then earliest finish. We have already discussed this earlier and we have already calculated this. Now, we will calculate how did we come up with 0 and 2 latest start and latest finish, and 2 and 4, latest start and latest finish. So we will not start with activity A anymore. We will start with activity H. So since our earliest finish is 15 for the last activity, our earliest finish for the last activity is 15, we will start our latest finish with 15. Our latest finish class minus the time will become our latest start. Again, our latest finish minus time, which is 2, will become our latest start. So for H, 15 minus 2 is 13. And then next, our latest start class will become our latest finish for activity F. So 13 minus 3 is 10. Now, our latest start will become our latest finish for the predecessor activity. But as you can see, class, for letters F and E, we have two predecessors activity. So we will get the smallest, okay? We will get the smallest latest start. The latest start for activity F is 10, and the latest start for activity E is 4. So since we will get the smallest, we will consider 4. So we'll put the 4 here, minus 2 is equal to 2. And the latest start will become here the latest finish. 2 minus 2 is 0. So in the same way, class, here, uh, we have here 8. So we will put earliest start, latest start rather, will become the latest finish. 8 minus 4, 4. 8 minus 4 is 4. The latest start will become the latest finish here. So 4 minus 3 is equal to 1. Okay, so that will be the network for our general fund rate incorporated. Okay, so once ES, LS, EF, and LF have been determined, it is simple matter to find the amount of slack that each activity has. So slack could be LS minus ES or LF minus EF. For table 12.3, we see activity A, C, E, G, and H have no slack time. So, when we say no slack time, class, wala sila spare nga time. These are called critical activities and they are said to be on critical path. Wala gyud ka na bang sarado gyud. The total project completion time is 15 weeks, and industrial managers call this as boundary timetable. So let us take a look at table 12.13. So activity A, B, C, D, E, F, G, H. Earliest time, we already computed this out from our network, and you can plot this. And then slack is LS, late start, minus early start. So late start, uh, LS is 0 minus ES. 0, LS minus 0, so we have 0. Is this a critical path? Yes. Ngano ko nung critical path ni? Because wala tay slack. Every time wala tay slack or wala tay excess nga time, sobra nga time, surplus nga time, we consider that as critical path. Next, activity B. Are we considering that a critical path? No, nga naman natay slack nga 1. How did we get 1? LS minus ES. So, 1 late start minus 0 earliest start. 1 minus 0 is 1. So, dili siya critical. Next, letter C. LS minus ES. 2 minus 2, 0. This is also a critical as along with activity E, activity G, and activity H. 0, wala siya slack. So, these are considered critical path. So, mao ni siyang naka-blue ang mga critical path dapat ni siyang bantayanan. These are activities A, C, E, G, and H. So, we should take a look, extra care for this activity because wala tay slack, wala tay room para masayop ani nga activity kay kuan igo-igo ra yun ang time nga allotted aning ato ang mga activities. Okay? Zero ang ato ang slack sa A, C, E, G, and H. So, A, C, E, G, and H. So, we have planning and scheduling project costs, so budgeting process. The overall approach in budgeting process of a project is to determine how much is to be spent every week or every month. So for example, class, you are given 1 million of a budget, you need to consider or you need to calculate out of the 1 million given for the entire year or entire month, how much should be allocated for 1 week or 1 day. You should have budgeting so that you will not be beyond the budget and mo excess na mo sa inyuhang resources. So there are 4 steps in budgeting. Identify all the costs with each of the activities, then add these costs together to get one estimated cost or budget. In large projects, activities can be combined into larger work packages. A work package is simply a logical collection of activities. Then, convert the budgeted cost per activity into the cost per time period by assuming that the cost of completing any activity is spent at a uniform rate over time. Using the ES and the LS times, find out how much money should be spent during each week or month to finish the project by the date desired. So we have here Gantt chart. So as you can see, mo ni siya ang number of weeks. In other words, class, kung activity A mahuman siya in 2 weeks kapin, activity B mahuman siya in 3 weeks kapin, activity F mahuman siya in 7 weeks. Can you analyze this? This is the number of weeks and these are the activity. So kung moingon tag activity G, mahuman ang activity G in 13 weeks. And activity H, mahuman siya in 15 weeks. So this is your Gantt chart of activities class. When you say Gantt chart, we can see here kanus ang mahuman ang kada activity. So activity C, mahuman siya in 4 weeks. Okay? So we have here the activity cost for the General Foundry Corporation. These are the expected time. Gimay expected time nato nga ato ang ma-achieve ang each activity. Activity A class, ma-achieve siya 2 weeks, activity B 3 weeks, and so on and so forth. So this is the budgeted cost. Activity A, budgeted cost niya is $22,000. Since activity A is done or can be accomplished in 2 weeks class, we shall divide 22,000 divided by 2. So each week, ang budget ra nato each week para sa activity A is $11,000. For activity B, mahuman siya in 3 weeks and the budget is 30,000. So, kung kuhaon na to ang budget niya kada week, divide na to 3, 10,000 kada week ang ato ang cost. For activity C, 26 iyang total, mahuman siya in 2 weeks. Kung i-divide na to ang 26, og 2 para makuha ang per week nga kuan, gasto, 26 divided by 2, that is 13, and so on and so forth. So the total budget class nato for activities A to H is $308,000. Okay? $308,000. We will move on. So, this is now, as you can see, ganina, mao ni siya ang Gantt chart. Ganina, ang Gantt chart, color-color pa lang to. But now, these colors, ato na siyang gipangbutangan og values. Diba? Niingon ta nga, ang atong budget for activity A is $22. However, activity A can be accomplished in 2 weeks. So, $22 divided by 2, week 1, $11,000, week 2, 11,000. we say that activity B can be accomplished in 3 weeks and ang atong budget is $30,000. So we will divide 30,000 by 3. We will distribute 30,000, 10 in the first week, 10 in the second week, and 10 in the third week. The same with activity H. Atong budget is $16,000. Naatay 2 weeks to complete activity H. So divided by $16,000 divided by 2. So each week na atay $2,000. And then, pila man atong magasto per week. For the first week, atong magasto week 1 is $21. $11,000 activity A, $10,000 activity B, so that makes it 21. Activity 2 still the same, and then total to date, this is the running balance. So kani siya per week kani running balance. So week 1, 21, week 2, 21. So how do we get the total to date? So 21 carry over. Then total to date pagka week 2, this is 21 plus 21, 42. Mo yun siya ang total to date. Pagka week 3 class, 10,000 ang budget sa activity B and 13,000 ang budget sa activity C. So 10 plus 13, this is 23. Activity to date, you will add activity to date sa previous. Unya, ang actual nga budget for that week, that makes it 65. 42 plus 23, 65. Then week 4, activity C 13. Wala na tayo nag-account diri sa activity A and B. Kaya nahuman naman siya. 2 weeks naman, 3 weeks. Week 4, activity C 13,000. Activity D 12. So that makes it 25. Activity to date, you will add the previous 65 plus 25. That's 90. So at the end of the project, mo total siya 308,000, which is the same ra sa atong kwentada diri ganina nga 308,000 at the end of the project. Okay? It is also possible to prepare a budget based on the latest starting time. This budget will delay the expenditure of funds until the last possible moment. The following table shows the latest start budget for the General Foundry project. Two tables form a budget range. Any budget can be chosen between these two values depending on when the company wants to actually spend the money. So here is our budget. So actually, the same na said ni siya ganina. So, kung kanus arasad nimo siya i-budget. So, ang total na to diri is $308,000 and this is per week. Okay? Mao ni siya ang per week nga igasto nimo. So, week 1, 11,000. Week 2, 21,000. Week 3, 23. And this is 23 plus 32 plus 23, 55. 11 plus 21, 32, and so on and so forth. So this is the total budget. Okay? This is the number of weeks and this is the activity and the total budget na to. So what's the difference between the using earliest start and the latest start? When we will use budgeting using the earliest start class, mas kumbaga our budget is spent early on pa lang. However, di ba, dire, mas-spend na nimo at the start of the week. Okay, magasto na nimo. Dayon, bago pa lang nagsugod ang project, makagasto na ka. However, kung late start na ka, dili pa nimo magasto dayon ang imuhang budget, di ba? Dugay pa siya kay mao man ni siya ang weeks. So, murag og kani siya Kani siya nga point diri nagasto na nimo pero same gyapon nga amount dugay pa siya nimo magasto kay late naman siya ang imong gibasihan dili man ang early start kundi ang late start. Okay? Costs are monitored and controlled to ensure the project is progressing on schedule and that cost overruns are kept to a minimum. The status of the entire project should be checked periodically. The following table shows the state of the project in the sixth week. It can be used to answer questions about schedule and cost. Okay, let us take a look at the table. So if you will remember earlier, activity A cost $22,000, activity B cost $30,000. For example, nahuman na to ang activity A. So 100% na ang completion na to sa activity A, meaning nahuman na to ang activity A. So expected na siya class nga magasto na to ang cost niya nga 22,000. Activity B, nahuman na sad siya, completed siya 100%. So, expected nga iyang budget nga 30,000, magasto na sad nato 30,000. Pero, ang actual cost niya class is 36,000. Okay? Balik sa taha, kaya na ako'y na ligtaan gamay. Budget cost na to for activity A is 22,000. Na-complete na siya, tanan, nahuman na. This is the value of the work. Pero nga ako atong actual cost is 20,000 lang. So naatay difference nga 2,000. Karon atong activity B 30,000 completed na pud siya. 30,000 iyang value pero ang iyang actual cost is 36,000. So natay difference nga 6,000. Next, 26,000 activity C 100% complete na siya na siya'y work value of work na 26, actual cost niya is 26, so 0 ang difference na to. Activity D, 48,000. However, wala pa siya na 100% complete, 10% complete pa lang siya. Supposedly, ang value of work niya is 48 because 10% of 48,000 is 48. Pero, ang actual cost niya class na nubra na ni 6,000 na. So, meaning natay difference nga 1,200. Sa activity E, 56,000 ang budget, 20% pa lang ato ang completion. So, this is 11,200 ang ato ang value of actual work. 20% of 56,000 is 11,200. But the actual cost is already 20,000, meaning ni sobra ta og 8,800 from the original budget nato nga dapat 11,200 lang ang 20% sa 56,000. Activity F, 30,000 ang budget, completed 20% lang gihapon. Unya, ato ang value of work dapat 6,000. Pero actual na to nga cost is 4,000, meaning nakasave ta diri og 2,000. So kung you will sum that up na atay 12,000 nga sobra nga nagasto, meaning we are already overrun or out of budget. Asa man ta na out of budget? Activity B, supposedly 30,000 lang pero nilapas tag 6,000. Activity D, supposedly 48 lang ang 10%, pero nilapas taog 1,2 kay 6,000. And then you can take a look here natin mga sobra-sobra na po tayo mga nakasave. But mas dako atong sobra ni overrun ta siya og 12,000. Kay supposedly, ang value of complete work should be 100,000. Pero ang actual cost na to niabot siya 112,000, 100 minus 112. So natay sobra nga 112,000 na sobra sa ato ang budget. Which you should be looking to it kay para di ka kulangan sa ato ang budget. So I guess that's all for this topic. Thank you very much for listening and have a great day.